to come back and look at this before the test, because I'm going to put one of these just like this, and I'm going to say solve it in 4 different ways. Sound good? So you might want to come back. Today's date is the 3rd. You might want to come back to May 3rd and just look this over right before the test, okay?
On the test, like our next test?
On your next test, on your circle test. I'm going to have one quadratic equation to solve on the circle test. Yes. That's me. Remember that picture of me thinking? That was me kind of thinking, yeah, I'm going to do that. Okay. All right. So the first thing we're going to do is we're going to set it equal to 0. So I'm going to take 3x squared plus 16x, and I'm going to add 5 to both sides to move it over and set it.
Not 16.
Sorry. Okay. Now, here's the deal. The next thing I want to do, and if you remembered yesterday, it worked out really nice where we factored out a GCF. I think it was 2, if I remember right. Okay. The problem is the greatest common factor of 3, 16, and 5 is 1, and that doesn't do me any good. So I'm going to have to factor this, and I call it the AC factoring method. Okay. Now, pay attention. Different teachers do it different ways. I'm going to tell you how I do it. Okay? Now, pay attention. So the first thing, notice this thing is not as simple as just figuring out 2 things that add to 5, or multiply to 5 and add to 16, because that 3 in front of the x squared is complicating things. You guys understand that? So here's what I'm going to do. I'm going to take the first term and I'm going to multiply it by the last term. So I'm going to take 3x squared and multiply it by 5. So what is 3x squared times 5, class?
15x squared.
So 15x squared is the product that I want to look at. Now, I need, ladies and gentlemen, for the sum of those to add up to 16. You guys understand that? So what are the factors of 15 that add up to 16x? So we could do, and I hear, let's just pretend we didn't know that. So we could do 3x and 5x, right? Those multiply to 15, but they do not add to 16, right? So is there another possibility we have? 15x and 1x, or just x, add up to 16x, and they multiply to 15. So this is the pair we're going to want to use. Bless you. Okay. So now, what we're going to do is this. We're going to go through, and we're going to replace the 16x with the 15x plus the x. Okay, we're just going to substitute that in. Now, I'll show you why that's nice. So notice, guys, 15x and x is just 16x, right?
Right.
So now I'm going to do 3x squared plus 15x plus, we'll say x, plus 5 equals 0. Now, notice I didn't change it. I just substituted an equal expression in for 16x. Now, why does that help me? Well, what I can do now is I can do these little baby parentheses out in front, and I can do something called factoring by grouping. You guys understand that? Now, if I look at the first set of parentheses, I see that there's a 3 and an x that go into both of those. Does everyone understand that? I could factor out a 3x. So if I factor out a 3x and I work backwards, well, 3x times what gives me 3x squared? Well, x. See that? Plus 3x times what gives me 15x? Well, 5. Now, if I look at the second parenthesis, I got to factor something out of that. And there's nothing really to factor out of that, so I'm just going to factor out a 1. You guys see that? And that will not change that parentheses at all. Now, why is that good? But now I'm going to factor out an x plus 5, because that's a common factor in both of this term here and this term here. Both have a common factor of x plus 5. So I'm going to factor it out. So I'm going to factor out the x plus 5, and what's left over? Well, what's left over is 3x here plus the 1, and that equals 0. You guys see that? I factor out. How did I get what?
1. Anything.
Okay, so let's go back. Again. Okay, let's go back. I didn't really like a lot of side conversation because I want to show this. Okay, does everyone understand where we got the 15x plus the x?
Mm-hmm.
Does everyone understand that we just simply substituted that in for 16x? Does everyone understand that I put parentheses? It's called factoring by grouping. When you have four things, you can do something called factoring by grouping. I just put parentheses around the first two things and parentheses around the second two things. You guys see that? Does everyone understand that there's a common factor of the first set of parentheses of 3x? Does everyone understand the only thing I can pull out, the only common factor of x plus 5 is 1? There's nothing else I can pull out of that. I have to pull something out. So if there's nothing I can pull out, I can always pull out a 1. You guys understand that? Now, then you've got to look at this one as two different things you can factor also. This term here and this term here both have an x plus 5 in there. Do you guys understand that? So we can unmultiply that out. We can pull it out, factor it out, just like we factored out a 3x on the first one. We can factor out an x plus 5 because notice there's an x plus 5 in both the yellow and the green term. You guys understand that? They're messy terms, but they both have an x plus 5. When I factor them out, I just take them out. Now, what's left over when I factor them out? 3x is left over. See that? And the 1 is left over. That's where the 3x plus 1 came from. You guys don't see that?
Why isn't it 2x plus 10?
What?
Because there's two of them.
No, because when we factor it out, we just take because it got distributed it in, right? So it got if the 5x plus the x plus 5 got distributed to the 3x, and the x plus 5 got distributed to the 1. Okay? We're just pulling it out. Okay? You guys see that?
Why? But it works.
Okay, now,
I agree.
the next thing we're going to do is we're going to use the zero product property rule. So remember, we have here one or both have to be 0. So we have one expression, x plus 5 has to equal 0, or 3x plus 1 has to equal 0. Okay? So now we solve for x and we get, let's see here, we can subtract 1 and divide by 3, and that gives us x equals negative 1/3. Did I do that too fast, or do you guys see how I did that? This one, all we do is subtract 5, and we get x equals negative 5. If you're confused with this one, I subtracted 1, and then I divided that answer by 3.
Oh, I could not see the negative, my bad.
Okay, question, Sophia.
So then, in this case, we aren't given a figure or a shape or anything, so we can't rule out the negatives.
Right, this is a blatant, in-your-face algebra problem. So you have to have two solutions. Yep. So this is perfectly fine to have negative answers. Okay? Because just put your geometry class aside for a second and just think algebra. Okay? All right. Guys, and as much as you think that this is crazy and all that, you're going to have to do it next year. So we might as well get it fresh. We might as well break the ice right now. You guys got it? You don't want to get in high school and have your teacher say you guys are a bunch of dummies because you don't know how to do this. You guys understand that? I don't know if they'd see that. Okay. Now, okay. So, any questions there? All right. Now, the next way, we're going to come up with the same answer, but now we're going to complete the square. Okay? So, again, that's something you need to know how to do in algebra. If you don't know how to do it, I'm going to show you now. Okay. So, ladies and gentlemen, pay attention. We're going to complete the square. Again, it's a little bit interesting. You're probably going to moan and cry a little bit, but you got to know how to do it. Okay, so I'm going to give you the steps to completing the square. Okay, so everyone write completing the square. And you will, in your math career, need to be able to complete the square at certain times. Okay, trust me. Just trust me on this. All right, now, here's the deal. We're going to use the same equation. We're going to get the same answer, but now we're going to solve it a different way. So here's how we complete the square. The first thing we want to do is we want to move C to the other side.
Oh, so you're going to add 5 to both sides.
Okay, now, this one is nice because they already did it for us. See that? So remember, in your formula, it's ax squared plus bx plus c equals 0.
I actually remembered that.
That's the standard form of a quadratic equation. Okay.
Where C is like the.
C is the constant. It's the number without the variable. Notice, guys, they already moved it over for us. Does everyone understand that? Okay. The next thing we're going to do, ladies and gentlemen, is we're going to make A equal to 1. Now, this is a more complicated one, but that's okay. We're going to make A equal to 1 by dividing everything by A. By dividing everything by A.
Oh, I get it.
Okay.
Divide both sides by 3x squared.
Hold on, we'll get that. Now, remember, A is the number in front of x squared.
So divide both sides by 3.
Divide everything by 3. Yep, you can kind of see where. After that, now here's the big deal. This is how we're going to get a new C. We're going to get a new C using the formula B over 2 squared. And I'm going to highlight that. That is a very important little point of completing the square. You take B over 2 and you square it. Now, we haven't done anything yet. All you're doing is just writing down these rules. We're going to come back and do it. I'm just telling you the rules so we can go through and do this as a checklist. You guys understand that? Okay, so we haven't done anything yet. Sam is kind of talking out loud, but we'll go back and actually do it. Okay, number 4. We're going to factor as a perfect square. Okay? We're going to factor as a perfect square. And we'll talk about what that looks like and how it works. And the last step we're going to do is we're going to solve and simplify. Okay? The last step is we're going to solve and simplify. Okay, now completing the square when you first do it is a little tedious, but don't get too, just keep an open mind here, okay? All right, so here we go. We have 3q squared. Oh, sorry about it. It's x. My bad. I changed it to x. Okay, so we have 3x squared. I'm just recopying the equation. Plus 16x equals negative 5. Now, they were nice, and they already moved c to the other side, right? If this was equal to 0, then we would move it. If this was plus 5, we'd subtract 5 to move it over. You guys understand that? Okay, now, the next thing we're going to do is we're going to make a equal to 1. We never want anything but a 1 in front of our x squared. So we're going to divide everything by 3. Everything by 3. Everything by 3. Okay. It's going to get a little weird here, but we can handle it. So when you do that, you're going to get x squared plus 16 over 3x, which does not simplify, equals negative 5 over 3. And we're not going to change it to decimals. We're going to leave it as fractions for now. Okay. You guys with me on that?
Yes, sir.
Now, our new C, I'm going to do it off to the side down here. My new C, okay, is going to be, and this one, right, this step, you're going to add this new C to both sides. I didn't say that, but we're going to add that new C to both sides, and I'll show you what we're going to do. So we're going to take B. What is the B now that we've got B, now that A is 1? 16 over 3. We're going to take 16 over 3. We're going to divide it by 2. Now, when I say divide it by 2, I'm going to put 2 over 1 because that's a fraction. And we're going to square the answer. Does everyone understand that? I'm hearing, so we're taking 16 over 3. We're dividing it by 2 over 1, and we're squaring the answer. Now, this is a complex fraction, but it's very easy. And I heard someone say it, and I'm very impressed. It's copy, dot, flip. That's how you do it. So this is going to be copy the top, dot, flip the bottom, which is 1/2. And then we'll square the answer. Does everyone understand that? Okay. Now, there's a couple ways to do this. I like to simplify before I multiply. So 2 goes into itself once, and 2 goes into 16 8 times. Okay. You guys see that? So now, what I'm going to get is I'm going to get 8 over 3, but then I've got to square that answer. Okay, so that's going to give me 64 over 9. That's my new C. Okay. Does everyone understand that? 64 over 9 is my new C. So what I'm going to do is I'm going to take that C and I'm going to add it to both sides. So now I'm going to get x squared plus 16 over 3x plus my new C, which is 64 over 9, equals negative 5 over 3 plus 64 over 9. Because I've got to add it to both sides. Relax. Now, the next thing I'm going to do is, if you don't mind, I'm going to erase this new C work. Do you guys have this new C work down here? Because it's in my way. Okay, I'm going to erase it. Okay, so now once I do that, what I'm going to do is I'm going to factor as a perfect square. Now, how do I do that? Okay, a perfect square is one parentheses with a square sign like that. Y'all see that? Now, it's very simple how you get the inside of this. You square root the first thing and you put that answer right here. What's the square root of x squared? X. Now, the next thing you do is you take the sign in front of b and you just put it down. If it was a minus, you put a minus. It's a plus, you put a plus. You just put the sign in front of b. You guys see that? Now, the next thing you do is you square root this and put it down into here. What's the square root of 64 over 9? 8 over 3. Okay. And that equals negative 5/3 plus 64 over 9. Now, let's go ahead and get a common denominator on the left side. What is the common denominator between 3 and 9?
9.
Yeah, we're having a 16 over 3.
Okay, but listen, when you factor something, that is the sum. That gets hidden in there. Remember, because here's the deal. If I FOIL out x plus 8 over 3 times x plus 8 over 3, it will come back to this answer right here.
Okay.
You guys see that? I factored it. You guys see that? If I took this, guys, if I actually multiply this out, if I actually took x plus 8/3 and squared, I'd multiply it again by x plus 8/3, I would get this without the square roots. You guys see that?
Whoa.
Okay. Remember, we're reversing the process. Now, here's the deal. Let's get a common denominator. What's the common denominator between 3 and 9?
9.
9. So all we have to do is multiply this top and bottom by 3. You guys see that? So this is going to be negative 15 ninths plus 64 ninths. Okay? What is 64 plus negative 15?
49.
What?
49.
So now we have equals 49 ninths, and that's a really good fraction. Okay, and we also have this over here, x plus 8/3 squared. Any questions on what I've done? Now, this process will always be the same. Right here, you're always going to square root the first thing and put that answer there. You're always going to put the sign in front of the b here, and you're always going to square root the new c and put it there. It's just the way it always is going to work. Okay? That's how you make a perfect square. That's the rule of writing perfect squares. Okay, now, why did we do that? Because now we have something completely squared equals something else. If something is completely squared, how can we get rid of something completely squared? The entire thing is squared, so we can square root the entire thing. That's why we did that. Now, if I square root the left side, what do I have to do to the right side? But whenever you square root both sides, you have to do plus or minus on the right side. Does everyone understand that? Well, because you always have a positive and negative solution possibility.
Right, but
Only on the right side.
Why only on the
Because think about it. If you have,
it's squared.
Yeah. Yep. Now, what do you have now? The square root cancels the square, and you have x plus 8/3 equals plus or minus. Cody, are you listening? the square root of 49 over 9. Now, we can actually do that square root. What's the square root of 49 over 9 equal, class? What? 7 thirds, right? So this is going to be x plus 8 thirds equals plus or minus 7 thirds. Now we can go over here and we can solve and simplify. We have two equations. We have x equals, and if we subtract 8 thirds from both sides to solve for x, we get x equals negative 8 thirds plus 7 thirds, and we have x equals negative 8 thirds minus 7 thirds. You see that? Now we have common denominators. What's negative 8 thirds plus 7 thirds? Negative 1 third. Does that answer look familiar? What's negative 8 thirds minus 7 thirds?
Negative 5.
Negative 15 thirds.
Into negative 5.
So that's negative 5. Does that answer look familiar? So what did we just do? We solved by completing the square. It is usually the one that teachers skip over the quickest and kids hate the most. But what happens is in algebra and especially in pre-calculus, it comes back and you need to do it. And what happens is kids never learned it and they have to relearn it. So it's not, if I did 5 or 6 of these right now for you, you would just see that you would do the same thing every time. It's just different numbers. You guys understand that? There's a lot of steps, but the steps pretty much are simple if they're nothing too bad. Okay, now what I'm going to do now is we're going to do the quadratic formula. Now, you have to understand what's going on here. Okay, so now I'm going to erase this. Now, you have to understand what's going on here. Okay, let me say it again. So what happens in math is your teachers give you these magical formulas, but math is the most unmagical thing in the entire world. Okay, now listen. Where does this quadratic formula come from? It comes from this. Instead of having just numbers in front of x squared, b, and c, the quadratic formula says this. If you just put an a for f in front of x squared, and you put just a generic b in front of x, and you just put plus c, and set it equal to 0, and you complete those steps that we just did, completing the square. So instead of, we would subtract c from both sides. You guys understand that? Then we divide everything just by the letter a. And then we would get a common denominator, and then we'd get a perfect square, and we'd square root both sides. If you perform that, and I've done it many times, but this is not an algebra class, if you perform those steps, if you complete the square on a general equation without numbers, you're going to come up with x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's what you just did. This formula, all this formula is the formula when you complete the square on the general equation with a, b's, and c's without numbers. Does everyone understand that?
That's true.
Now, remember, the quadratic formula only works when it's set equal to 0. So this one, we want to go back and we actually want to set it equal to 0. So we got 3x squared plus 16x minus or plus 5 equals 0. Do you guys understand that? Now, when you're doing the quadratic formula, you always want to list out your a, b, and c. So in this case, what's my a, class? You're using this equation. A is 3. What's b? 16. What's c?
5.
It's 5. And remember, it's not negative 5 because we had to move it over. And then it's just brainless math. Hi, Kendi. What's up?
Miss Williams said to give this to you and say thank you.
Can you just put it where it goes? Thank you, Kendi.
Not Kendi.
All right.
Candy,
So now,
I don't think we're
okay, Sam, we just have to relax that Kendi's here. We're excited, but we're going to move on. Okay. All right. So now we have x equals negative b, so negative 16 plus or minus the square root of b squared, so 16 squared, minus 4 times a, which is 3, times c, which is 5, all over 2a, which is 2 times 3. Okay, so all we're doing with the quadratic formula is plugging numbers into the formula. But remember, this is not a magical formula. This formula came from completing the square. Does everyone understand that? So now, we're just going to crunch some numbers here. Well, you got negative 16 plus or minus, well, what's 6? Is that 256?
Yeah.
So 256. Now we're going to do the math. 4 times 3 is 12, right? 12 times 5 is 60. Am I right? So this is going to be minus 60 all over 2a, which is all over 6. Questions? You guys with me on that? Okay, now, what is 256 minus 60? 196. That sounds like a great number. So now we have equals 16 plus or minus the square root of 196. Notice it's a positive. If it was a negative, then we wouldn't have any real solutions. You guys understand that? Then your math teacher in high school is going to have to teach you about complex and imaginary numbers. But that's not my job. I'm a real number teacher when I'm here at Jenkins. What's the square root of 196, class? 13, right?
Right.
So now, no, 14, right? 14. So we have 16 plus or minus 14 all over 6.
What?
See that what I did?
I do.
Now, we're going to add the two numbers on top and divide by 6.
32. 30.
What's that? Okay, hold on. Oh, by the way, this is negative 16, right?
Oh.
Okay, so that's negative 16. So remember, it's negative b, so negative 16. All right, here we go. So now, what's negative 16 plus positive 14? So that's going to be negative 2 over 6, which gives us what? Negative 1/3. Does that number look familiar? Okay, now, what's negative 16 minus 14? Negative 16 minus 14. What is that? That's negative 30 over 6. And what is negative 30 over 6 reduced to? Negative 5. So there's our answers using the quad formula. Okay, does everyone understand that?
I like the quad formula.
Okay, but first of all, yes, the quadratic formula is a good way to go. If I looked at this problem and I just scanned it over quickly, I would probably just put it in the quadratic formula. I like to factor, so I may try to factor it. But if you're not sure, you can always just stick it in the quad formula. But no, the quad formula came from completing the square. And there's going to be times in math where you have to complete the square. You can't use the quadratic formula because it's not available to you. Okay, now, here's the deal. I want everyone to go on Desmos.com. Well, you're going to need to have something squared. And when you're writing equations of circles, and I'll show you, when you're writing an equation of a circle, you're going to have to complete the square. Okay, that's fine. All right, so I'm going to go on Desmos. Okay. Yeah, there's going to be times when you're going to have to complete the square. It's pretty rare, but there are some times. Okay, I'm going on Desmos.com. Now, here's what I want. I want someone to give me the equation in standard form the way we had it set up for the quad formula. So y equals what? Y equals, what was it? 3x squared, right? Let me see if I can square it. Okay. Shift 6 gets squared. What was our next one? Minus 16x? Positive 16x. Positive 16x, right? So it's plus 16x plus 5. Okay? Plus 5. And we don't have to say equals 0. Okay, we just put it in like that. Okay. Now, what we get is we get something called a parabola. Okay. But what we're really concerned about, does everyone have this in your Desmos? Okay. What are we finding on the graph? We're finding the 2 points where it crosses the x-axis. So if I click on that point right there, it's -5. You guys see that? When I go on this point over here, it's -0.333 repeating, which is what? -1/3. So what you're really doing when you're solving is the solutions to a quadratic are where it's crossing the x-axis. You guys understand that? Now, if you get a negative square root, all that means is your parabola just is above or below the x-axis and it doesn't cross it. That's all it means. You guys understand that? Wyatt, question.
Can we use decimals on the test?
Maybe, but you'll still have to do the other ones. Okay. So,
Man, I got a living.
We can use that to check our answer.
I haven't decided what I'm going to do yet. But again, what we did is we did three. Desmos is the quickest way to see it, right? Here's the problem though. Desmos is always going to give you a decimal, and sometimes we have a square root. So it depends. I haven't decided how I want to see this on the test. So here's what I want everyone to do. Okay? That's because you forgot to put x squared.
I put x squared. Let me see. Well, then it wouldn't be.
You put it in exactly as it is. It's just a straight line.
Yeah, and it's blue.
Are you on Desmos?
No.
Okay.
Y equals.
Now, here's what I want you to do. You have one homework problem tonight.
What?
Oh, we do.
It's due tomorrow. First thing. Okay. You're going to do 4 different methods on this problem. You can start now in class. I'll give you 5 minutes. Everyone get out a piece of paper.
Oh.
Now, with Desmos, when you use Desmos or your graphing calculator, you need to draw a rough sketch of it. Sound good? You don't have to make it a perfect graph. So, what I'm going to do is I'm going to give you a new equation, and you're going to solve it 4 different ways.
Wait, did he just?
Factoring, completing the square, quad formula, and graphing.
We can't use Desmos for the graphic one?
Yes.
Wait, we can?
Yes.
Oh.
Oh, no, I'm doing a normal. Wait, do we have to do the graphic one, or can like I do the quadratic?
Everyone sit down. Listen up. Okay. So, here's how this is going to work. Okay. Let me explain this because I was not clear. It is my fault that I am not clear with you guys. So I'm going to say right now that I need to clear this up. Okay, so let me show you what's going to happen here. In a minute, I'm going to give you an equation. Okay, you're going to solve this equation and you're going to show all your work on that piece of paper. You're going to solve it 4 different ways. The first thing you're going to do, think of this as 4 different problems. The first thing you're going to do is you're going to factor it because I've given you a problem that factors. So you're going to go back either to the video or your notes and you're going to look how I factored it and use the zero product property rule. Okay. Well, that's why we recorded it. And that's why you're taking notes, Cody. All right. Now, after you factor it, you're going to come back and you're going to perform completing the square on it. And you're going to do all the steps I showed you how to complete the square. And after you complete the square, you're going to use the quadratic formula on it. And you're going to do all the steps of the quadratic formula, and you're going to get an answer. And after that, you're going to put it into Desmos or your TI graphing calculator, doesn't matter. You're going to draw a little sketch off to the side, and you're going to put little arrows to where the solutions are. Does everyone understand that? So what are you going to notice about all of the answers in your 4 problems? They're all the same. But you cannot just give me the answer. You have to show me all the work. I need to see the work. Obviously, could you go to Desmos first and get an answer and make sure? What I would do is probably do Desmos first and make sure you understand where the answers are and then work backwards and all that. It's on video, okay? So watch the video. All right, so here's your problem. This is due first thing tomorrow. It's basically 4 different problems. It's 2x squared plus 11x plus 12 equals 0. Okay, so you're going to perform that. So again, if it were up to me, I'd probably start with the Desmos, have a sketch, and look and see where those answers are. And then you can go back and do factoring, completing the square, and quad formula on it. Okay, does everyone understand that? Are there any questions? If you put it into Desmos and you find the answers and you do the quad formula and you get a different answer, you know either you put it wrong in Desmos or you did the quad formula wrong, right? Sam, did you see what your mistake in Desmos was? Okay, we'll take
What was that?
No, he didn't.
a look. Yeah. Okay. All right, I'm going to let you guys get to work. I'm going to stop sharing.